Okay, I'm here finishing up page 5 that was left off the original video answer key. We're making license plates in the fair country of Albonia, and they have 3 letters, and the letters can be any of those 5 options, and then 5 numbers, and they can be any of the 10 digits 0 through 9. Count carefully, that's 10. With repeats, it could be 5, and then it could be any of the 5 and 5 again. So that's going to be 5 to the third times, and then this is just 10 factorial over 5 factorial. We'll chop off the last of those digits. If you multiply that out carefully, you'll get 378 with 4 zeros. What's the probability then in problem 28 of choosing 3 black marbles all at once out of a bag of 10 black and 16 white marbles? Well, if you've got 10 black marbles here and there's a total of 16, that's the start of our probability. But then taking 3 all at once is no different than taking 1 and keeping it, and taking a second and keeping it, and taking a third. And it helps to think about those probabilities as happening one after the other. So 10 over 16 times 9 over 15 times 8 over 14. And then to simplify this, just do a little bit of canceling. The 8 will cancel with the 16 and get a 2. I can cancel 5s here from the 10 and the 15. I'll get a 3 and a 2. These 2's cancel. And then the 3 here will cancel with the 9 and give me a 3. And in the end, I'm just left with 3 out of 14. 3 out of 14. Check that on your calculator, though. Then in 29, what is the probability that a family of 6 children consists of exactly 4 girls? And then that would mean and 2 boys. Well, this is a binomial experiment. Look that up in this chapter. The simple formula is that it's going to be NCR over 2 to the n, which in this case there's 6 children, 6C, and 4 girls, all over 2 to the 6th. 2 to the 6th is 64, and 6C4 is going to be something I'm not sure, probably 15. I'll double check that though. But again, you can take your calculator and work that out. Moving on to the next one, 2 or fewer left-handed children. If we're in this family of 6 children, it's part A and part B. 2 or fewer means what's the probability of 2 lefties? Then you could say the probability of just 1 lefty, and then the probability that you have 0 lefties or all righties. So you've got 3 probabilities to figure out here. To do this, then what you do is I'm getting off camera here. What you do is you say, well, the chance of 2 lefties, the chance of 1 lefty is 0.1, and you say how many lefties am I going to have, and you raise it to that exponent. The probability of being a righty is 0.9, and you're going to have 4 of those. And then the number of ways you can mix 2 lefties in with 4 righties is 6C4 again, okay? And find that probability. And then the chance of 1 lefty is going to be 0.1 to the 1 and 0.9 to the 5th, and then 6C5 or 6C1, that'll be the same thing. And then finally 0.1 to the 0, well that's just 1, and 0.9 to the 6th is going to give you a decimal, and then 6C6 is also just 1. So really, when you get down to the extreme case of all righties, you just figure out what's the chance of being righty and then do that 6 times. When you work this out, you can see in the answer key what that is. I'll type in one of these. This middle one, 6C5, that's 6. So 6 times, and then 0.1 to the 1 is just 0.1, and then times 0.9 caret to the 5th, and that gives me 35.4%. Okay, so you can do the other 2's and check that with the other page of the answer key put online, but I really wanted to show you how to do this and talk about it a little bit. This is the all-important binomial expansion. Alright, so when you expand a binomial like this, there's a simple pattern, and that is that the first term here, in this case it's the x, is going to start off to the 15th, and then the next term will be x to the 14th, and the next term will be x to the 13th, and it's going to count down. And at the other end, it's going to be minus 2 to the 15th, and then minus 2 to the 14th, with all of these parts being multiplied together. So you're going to have always 3 parts, counting from one end going to the left, counting from the left going to the right. But you see, this is going to be the negative 2 to the 0 power, that's just 1. And then this part here is always just going to be 15 C15 and going down by 1. This one here will be 15 C14. That's the entire thing. But we're just asked what's the first term, so that's x to the 15th. And the last term here is just negative 2 to the 15th. Well, keep that negative 2 in parentheses. Negative 2. Whoops, I put it out of parentheses there, but if I put it in parentheses just to make it clear and raise that to the 15th power, an odd number is going to give me a negative sign, negative 32,768. Negative 32,768. Okay. Now the sixth term here, this is where we're going to count in to the sixth one. So we know it's going to start off with x to the 15th, then x to the 14th, then x to the 13th, then the 12th, and the 11th, and that's 1, 2, 3, 4, 5. So the sixth is going to be x to the 10th. And then the next parentheses is going to be the negative 2 raised to whatever exponent plus 10 gives me 15, so that's going to be 5. And then the next one is going to be 15c, and then it's counting down from 15, 14, 13, 12, 11, and that's going to be always either one of these two exponents. It does not matter. 15c5, 15c10, take your pick. They're both going to give you the same answer. So when we do that, I'm going to do 15, then hit Math, go to PRB, choose the NCR, that's the third one, and then do 10, hit Enter, that's 3003. Oh, 3003. And I'm at negative 2 to the 5th, I happen to know is times negative 32. You can check that out. And that's then x to the 10th. So just to fit it on the page here, it's going to be negative 96096 x to the 10th. That is the correct answer for that one, and that one. All right, there's page 5.